Welcome to 3 examples on determining the values for which a rational expression is undefined. The main thing to remember is that a fraction bar means division, so if we have the fraction a over b, this means a divided by b, and because division by 0 is undefined, to determine the values where a rational expression is undefined, we need to determine the values for which the denominator would be equal to 0. So looking at our first example, the rational expression is undefined when the quantity 4x minus 32 is equal to 0. So let's solve the equation 4x minus 32 equals 0. First step is to isolate the variable term, so we add 32 to both sides. Simplifying, negative 32 plus 32 is 0, so we have 4x equals 32. To solve for x, we divide both sides by 4. And we have x equals 8, which means we would have division by 0 when x equals 8, and therefore the expression is undefined when x equals 8. We could have also solved this equation by factoring. Let's show that method as well. Beginning with the quantity 4x minus 32 equals 0. If we factor the left side, the greatest common factor is 4. If we factor 4 out of the left side, we'd be left with the quantity x minus 8. This product is equal to 0 when the factor of x minus 8 equals 0. To solve for x, we'd add 8 to both sides, giving us the same value of x equals 8, where the expression is undefined. Looking at our next example, the only difference here is that we have 2 binomial factors in the denominator. So this expression is undefined when the quantity x minus 10 times the quantity x minus 4 is equal to 0. This product equals 0 when the factor of x minus 10 equals 0, or when the factor of x minus 4 is equal to 0. Solving for x here, we add 10 to both sides, giving us x equals 10. Solving for x here, we add 4 to both sides, giving us x equals 4. Which means the rational expression is undefined when x equals 4 or x equals 10. Notice how we do not consider the numerator when determining the values for which a rational expression is undefined. And for our last example, the only difference here is the denominator is not in factored form. The rational expression is undefined, meaning we have division by 0 when the quantity x squared minus 9x minus 10 is equal to 0. So the left side factors into 2 binomial factors. Because the first term is x squared, we have a factor of x here and x here in the first positions of the binomial factors. And then for the second terms in the binomial factors, we're looking for the factors of negative 10 that add to negative 9. And because negative 10 times 1 equals negative 10, and negative 10 plus 1 equals negative 9, the 2 factors we're looking for are negative 10 and positive 1. So one factor would be x plus 1, the second factor would be x minus 10. Of course, the order of the factors don't matter. This product is equal to 0 when x plus 1 equals 0, or when x minus 10 equals 0. Solving for x here, we subtract 1 on both sides, giving us x equals negative 1. Solving for x here, we add 10 to both sides, giving us x equals 10. So these are the 2 x values that make the denominator equal to 0, and therefore these are the x values where the expression is undefined. So we enter x equals negative 1, comma, positive 10. I hope you found this helpful.